Hello and welcome to another episode. I am here with Glenn Sanders of Zaxcom, and I'm excited by what you've brought some toys today, and I'm excited to show everybody and excited to hear about them. So I guess let's start with what have you brought?
We have been working very hard on some new technology, and that technology has, by the time this goes online, will have been released. So that technology is a new wireless transmitter technology, and the first thing that you might notice about this transmitter on a surface level is it's ridiculously small. So it's called the Zaxcom ZMT for Zaxcom Miniature Transmitter. And the miniature transmitter is almost exactly the same size as a Zippo lighter. Needless to say, we wanted to take our technology and just push it to a level where just no one has gone before.
And just to give people an idea, if we can cut to the overhead just one more time, Glenn, say a few words so people can see that not only is it working.
Oh, okay. Well, that's right. I'm using it right now, which is why my lav is just wired outside of my shirt. And you can see my audio reflecting on the ZMT's meter. And this is actually what you're listening to right now. And we have a lot of very, very excited customers. It's been in beta test for a number of weeks. It is absolutely FCC approved, IC approved for Canada, and will be CE approved quite shortly. So, it is absolutely ready to go. There's a lot more here than just it being a small transmitter.
Right.
First of all, it is the smallest transmitter, smallest professional transmitter. It is the thinnest professional transmitter. It has very rounded corners. So, when wardrobe gets a hold of this and they put it under clothing, it will seem a lot smaller even than it is because of the fact that there are no sharp corners. Mm-hmm. Before I really get into the technical part of it, what we wanted to do with this was come up with a mechanical design that was absolutely second to none. We wanted this to be as rugged as it can be. The case is gasketed, so around the battery door we have a rubber gasket. Around the back of the unit where the hinges are for the battery door, we have a rubber gasket. And changing the battery, all you do is pull it open. It's magnetically sealed.
Since you're talking about the battery, since you mentioned the battery, talk about the battery in a little bit more detail.
Well, sure. The battery is a common battery. It's an NP50 by Fuji.
You have one right there, right?
We do have one here, which is actually not the Fuji brand. It's one of the aftermarket brands. Mm-hmm. But with these batteries, we're actually able to get a maximum runtime of approximately 5.5 hours. So when you think about that, you have to think about what we're doing to get that. I mean, basically you have a transmitter that is a Zaxcom transmitter, and the feature set of it is absolutely no compromise, meaning that it's a transmitter up to 75 milliwatts. Mm-hmm. It is a ZaxNet receiver, so it is receiving remote control. It is an audio recorder. It takes a micro SD card right in the pack. So, we're doing all of those things, including, by the way, never clip. So, what you give up with this transmitter is absolutely nothing. In fact, there's a new feature, which is we have audio output from this as well.
Audio output how?
Through the extra pin on the mic connector, we're able to output monitor audio and time code. Uh-huh. So if you have this transmitter, you can use it to jam other transmitters. You can use it or other Zaxcom transmitters with recorders. You could also use it to jam cameras or anything you want. Because you do have a time code out on the connector. You just have to have a cable for it. This also has our wireless QC feature. So if you hold it up against one of our ERX receivers, you can actually hear the audio from the transmitter, right through the ERX receiver.
So what kind of range is that?
Well, that's pretty limited range.
Like a foot or two feet?
It's maybe 4 or 5 feet maximum.
Okay.
Yeah.
So what I really love about that is you go to Wire Talent, you have the pack. A pack like this, you're going to hide it, and you're going to, it's not really going to be easily accessible. You want to listen to it before you walk away from the talent, and if the mixer's off doing something else, or you can't get to the cart, you are the mixer and you're wiring talent, you can just bring a little ERX and just sort of listen to it right there.
Well, that's right. And when you think about it, if you can't monitor the transmitter locally, physically at the transmitter easily, because you can't plug into it, you can't do anything once it's on someone. This way, all you have to do is stand near them, and you can hear that through the ERX receiver. So it's a really, really big feature to have the wireless QC.
And just to make sure it's clear for everybody, the monitoring range is a few feet, but the Zaxnet range, the kind of telemetry and the timecode range, that's much
Oh,
greater,
that's right. Yeah, that's because that's a high-power Zaxnet transmitter from the sound card. So like with any Zaxcom wireless, from the sound card, you're able to not only remote control the transmitter, remote control the audio gain, you're able to go and control power roll, which I want to talk about quite extensively. But yes, from hundreds of feet away, you have full remote control. And when you're using this with a Zaxcom recorder or a Zaxcom mixing control surface, you've got the input trim pot right on the surface, and you're controlling the transmitters on the actors during the shot. It's absolutely true remote control, and it is an amazing feature for film and TV.
Yeah.
And the integration just makes it even more so, if that makes any sense. Just a very valuable thing.
Yeah, and one thing I have to say is you have to get your hands on this, because the build quality is really quite spectacular. Frankly, it doesn't feel like the earlier generation of transmitters. It feels much more solid.
Well, if you look at the transmitter, inside it's basically solid metal, okay? So we have the top piece, which holds the microphone jack and the antenna, and it is absolutely, Peter, you can feel it and see that it's just absolutely it's a solid brick. So it's a full metal implementation. The outside is our nylon polymer case, so that if anything ever would happen to the case, it can be quickly changed, and you could, for just an hour's worth of labor or less, have a transmitter that looks brand new if anything were to happen. It's very rugged, and it really takes a beating, even much better than metal cases do.
Yeah, and it's splash proof. They're with the exception of the SD card slot, which I think could be solved with some tape or something.
Oh yeah, well the SD card slot, it's a little small to see. Maybe if we can go to the overhead camera. So we have the slot. You can see it on the side right here. You can see the card is in it. That can certainly be covered over if you're using the memory card in there. If you're not using the memory card, there is a rubber plug that would go in there. So, it's easy enough to seal that up.
Yeah.
When we have something that is this small, you certainly have to design these things within the constraints of the physical components that you're trying to work with, whether it be a mic connector or an antenna connector or a battery door.
Sure.
There's only so many things you can do.
And I think it's a reasonable sacrifice to make, to not have protruding parts.
I agree.
Like a flap or something like that.
Well, that's right. Yeah, we certainly could have gone with a flap. That was considered. I wish on that one point we could have done a little bit better, but I do not see any reason that either you use the rubber plug or you cover it with a little tape if you want to. Right. If you're in a situation where you're going to have
right.
water
Moisture. Yeah.
Possibly coming into it.
The other thing we should talk about is, typically in small electronics like this, heat is an issue.
Well, absolutely. And the good news is there is literally no discernible heat output from this. Okay. I mean, even sitting on the table here, it is only very, very slightly warmer than the table surface itself. I mean, it's just very cool. This is extremely efficient. And what I want to talk about here is what I call the big truth about these things. That if you look at digital circuitry, digital implementation, when I say digital, I mean 100% digital wireless.
Right.
If you look at it, it can be as power efficient or even more so power efficient at this time than the older analog technologies, whether they be the companded older wireless or the digitally implemented companded wireless.
And is that because of all the advances in digital transmissions that have been brought about by cell phones and those kind of Wi-Fi?
Yeah, there's a lot of advances that are out there, and those advances are advances in power consumption of different chips, A to D converters, chips that we use in the transmitter. So there's many, many efficiencies that we've been able to utilize that have actually pushed the digital wireless beyond any analog implementation of wireless microphone when it comes to size, and also power consumption. Because if you look at everything we're doing off of a battery that's this small, what you've got is a transmitter, a receiver, a recorder, an audio processing system. You have all of these things running off of this battery for roughly 5.5 hours. So, by any metric you want to use, there's no advantage to analog wireless over what we have when it comes to this digital implementation. So just seeing the what we've done in something that is as thin as it is and as small as it is and well-rounded as it is, like I said, we put a lot of time and effort into this thing, and I am so thrilled with the results. You have no idea.
Congratulations. I want to get back to the 5.5-hour battery life.
Sure.
Is that under optimal conditions? And you mentioned a feature that I think is worth talking about in this context, power roll.
Well, that's right. 5.5 hours is under standard operating conditions. We have a...
What power output?
That would be 50 milliwatt
50
output.
Milliwatts, which is, I have to say, plenty.
Yeah.
Depending on the individual circumstance, but for most circumstances, 50 milliwatts is a lot.
Well, we do have, it'll do 75 milliwatts. Okay, so by 75 milliwatts, you'll probably lose about 10 minutes of running time. It's not a lot, okay? But what we do have is power roll. Power roll is something that we invented and patented, and it works automatically with all of our recorders. So, and you could also trigger it from just the IFB transmitter as well. What power roll does is it tells the transmitter to go into a lower output situation so that you save energy when you're not rolling. So by doing that, we can actually double or triple the runtime of a pack. So if all you're really interested in is just making sure you can get through the start of the day to lunchtime, and you're a little bit concerned that 5.5 hours might not do it, utilizing power roll would easily extend your runtime from up to 7 to 10 hours or so.
And is that an option? Can I defeat that?
Oh yeah, you can absolutely defeat that. Yeah, there's no problem with that. I think that battery life, obviously is an important thing, and if you can maximize that battery life by, adding features, and when it comes to ZaxNet, it just helps to highlight the importance of ZaxNet, not only in transferring, audio gain commands and timecode and IFB, but, realizing that we can save a tremendous amount of battery energy utilizing ZaxNet. So if you have, let's say, 10 transmitters out there, and you're not using a Zaxcom recorder, you can just go right over to the IFB transmitter and tell it to put all the packs into power saver mode. And by doing that, extend the running time.
Sure. And I think, people realize there's always a trade-off, right? These packs are small and they're meant to be hidden, and so there's those competing interests of the size versus the battery life.
Well, that's right. And what we've tried to do here, and I really think we have absolutely accomplished the goal, we wanted to, I'm just going to do that. There we go. Okay. What we wanted to do is come up with a pack that wasn't a special pack. It's not the pack for the diva, for the actress that, is wearing the skimpy costume or what have you. It's an everyday pack, because there's no limitations with this pack. You would, have every feature that we have, plus audio quality that is frankly even better than what we put out in the past. And let me explain that, because I think that is a very important thing. What we have now done in this pack is we've gone to a new A to D converter. That A to D converter is basically 108 dB. The converters we used to use were 102 to 3 dB. So we've picked up another 5 to 6 dB in basic dynamic range. Add on that another 20 dB for never clip. So you get a maximum dynamic range of this of 128 dB, which is far beyond that of any lavalier microphone.
Sure.
So you're going to clip the lavalier microphone.
I was going to say it's far beyond most lavalier mics.
Yeah, you're going to clip the lavalier microphone before you're going to clip the transmitter. And what you're going to have here is all that dynamic range and absolutely no limiter distortion. It is fully linear. So post-production is going to get amazing audio from this. And, again, remember that there's no companders, whether it be analog companders or DSP-based companders. There's no noise reducers. It is just absolutely linear, unprocessed audio that post-production is going to love and is just, frankly, going to be the best audio quality of any wireless transmitter ever produced. I mean, the specification for dynamic range is just really untouchable.
Amazing. That's great.
I do want to speak a little bit about ZHD, because I think that's really important. I do want to talk about ergonomics a little bit more, and just some of the things that we've done that I think are going to make this thing just really easy to use on a day-to-day basis. As you can see, it's got the OLED display, which is, again, a very neat display, giving you a lot of information. In fact, we show you the running time code on the display, and you see the audio meter. So there's a lot there. You can see the status of the transport. You see it says stop on there, and of course the transmitter frequency. You see how many hours are left on the memory card. It's showing 25 hours left. We have put a new menu system into the transmitters, which this is actually from the older wireless system, but there's a menu that has all the transmitter functions, whether it be transmitter power, transmitter mode of modulation, that type of thing. There's a record menu that you can use to format the card, basically whether it's going to loop record. So, it's really, very, very straightforward. A home menu, setup menu, time code menu for jamming and what have you, whether you want to jam through Zaxnet or you want to jam through the mic connector.
Sure.
Audio menu, which is for dynamics and different things like our downward expander. The Zaxnet menu, so you can say what frequency it's going to transmit or be monitored on. I shouldn't say transmit because it really doesn't transmit, but what the receiver frequency is. So really, you've got quite a nice segmented system in here that is just really, really easy for people that haven't been familiar with Zaxcom Wireless to just be able to pick the unit up and just use it.
Right.
Because as we all know, a lot of people are hesitant because they just want a transmitter that they turn on. And let's absolutely get this right. A Zaxcom transmitter, you turn it on and you're ready to go. You don't have to do anything.
Right.
But if you do want to do these things, it is very easy to go through and do them.
Mm-hmm.
Another thing I want to point out is that the system, because of ZaxNet, is very, very automatic. Okay, when you power the unit up, it'll automatically go out and look at the ZaxNet signal. It'll jam code. It'll go into record. So if you have this on a big show, you're not running around trying to jam transmitters and make sure that they're properly working.
Right.
That's the same thing we do on our ZFR recorders. So the system basically is set up to take care of itself. It's also set up recording-wise to make sure that when you turn the unit off, if you haven't stopped the recording, okay, well, first of all, if you turn it off, it'll stop recording automatically, okay, which is something new for this transmitter, because this transmitter you do turn off through software rather than a hard switch. So it knows to turn itself off. But if you do have open files on the card, when you switch the transmitter on, it automatically closes those files. You don't have to have a technician come in and have to say, okay, well, how much did I record? Where am I going to close it?
Right.
Okay, do I have to close it? And if you pop the card out of the transmitter while it's recording and just send it off to a Mac or PC in post, the file will automatically close in post. So there's no chance of you sending files or cards to post that are unreadable. I mean, this is all part of the MARF file system. Again, all to take the trouble and responsibility out of doing these things. I mean, when you record on a Zaxcom recorder or ZFR, it is trouble-free, it is automatic, it is ready to go. And that's some of what we do, which I think is really quite unique and important.
Sure. Yeah. No. That's it. You need it to be bulletproof and reliable.
Exactly. I mean, that's what we've been doing for so many years now.
What's this lanyard feature I keep hearing about?
Okay. When we were designing this, we were actually working with a sound mixer who was on a production where there really wasn't any place to put the transmitter. So, because there really wasn't any clothing to mention. So what they wanted to do was to take the transmitter and basically hang it from the neck on a chain. And just cover it with like a little leather or something, or some feathers or something, so that you wouldn't even see the transmitter. And it is absolutely small enough that you could do that, So to that end, what we did is on the top of it, we included a screw that you can unscrew and then screw in a little loop, so you can put a chain around it, so that you can actually hang it on someone's neck like a piece of jewelry.
All right.
And I do want to point this out because when we did design this thing, actually I'll put down the one I'm transmitting with, but when we designed this, the view of this was design it to be jewelry. Okay, use jewelry hinges to hold the battery door in, which we did. Come up with an ergonomic, not only ergonomic, user-friendly thing, but something that was very attractive. In fact, you can even hear the mechanism of the door closing.
Yeah.
It's that solid. And if you try to flex it, I mean, it's absolutely like a little brick. But the look of this thing, just the, button placement, OLED display, rounded corners, rounded edges.
Yeah.
I wanted someone to look at this and say, you know what? That's something that I want to own. That's something that I want to give to, my talent to use, because they're going to look at that and say, wow, that's really well done. So, looking at it from a jewelry / ergonomics / artistic perspective, I think gave us, a challenge that I really wanted to meet. And I think from the response of people like yourself, I think we've really done a nice job with that.
Yeah, it's nice to see you proud of it.
Well, I am. I mean, look, I'll take some credit. The joke is that someone said to Colleen, she was showing it to a customer, they said, "Who designed that?" And she's like, "Well, we did." It's like, "Oh, okay."
Yeah,
it
feels very solid. So it's got ergonomics, it's got range, it's got sound quality, it's got battery life.
It's no compromise. I mean, it really is, like we said earlier, an everyday transmitter. The only complaint is it's probably too easy to lose because it's too small. You know, but that's okay. You know, not a problem. Just to recap the features.
Yeah.
75 milliwatt output, 5.5 hour runtime, Zaxnet remote control, 100 megahertz tuning range, 128 dB dynamic range, all in a package that is the smallest in the industry and the thinnest in the industry, and a package that just does not get hot, so it's very friendly to
for talent.
For the talent,
Yeah.
they're going to love it. So, you know, it is, as we said, it's shipping now.
What's the price?
Price on it is American list price is $17.75. So it's exactly the same price as our TRX LA transmitter.
Right. Firmly reinforcing that it is an everyday transmitter.
It is an everyday transmitter. There's no reason that you couldn't have, you know, 10 of these things instead of just, you know, having one, because, you know, you don't want to sacrifice things like runtime or what have you. It is absolutely something that we think the sound mixers will standardize on and start moving away from AA batteries, because certainly the way the world is, I mean, using a battery that's rechargeable is good for everybody.
Yeah. So we should talk about how this is shipped in terms of batteries.
Okay.
Does it come with this battery, and what is this battery?
Right. Well, this battery happens to be a standard Fuji NP50 battery. So it's very, very easy to get. Customers can buy them on Amazon for about $17 each.
Right.
The reason that we don't include the battery is very simple. I need to absolutely assure the customer that they're going to get a good battery. If they don't get a fresh battery, a battery that is packaged with the unit and maybe sits on a shelf for a period of time, I can't guarantee that. And you can't guarantee that. So if the customer purchases their own battery or purchases it from you separately, you know you've got fresh inventory. So I am not going to put the customer in a position where they're going to pay me for a battery and I can't assure that they're getting an absolutely fresh, good battery because of that problem.
One thing I think maybe people don't know is if a lithium battery self-discharges below a certain level, it's toast. It can't be revived, or it loses a significant capacity.
Well, that's right, Peter. And there's also another situation where shipping of batteries, lithium batteries,
logistically now is challenging.
It can be problematic. Yeah. So we wouldn't want to be in a position where we would have to ship our product to, you know, a customer in a foreign country, and it couldn't ship because it had the lithium battery in the packaging.
Yeah, it is a funny thing. I mean, I think I like the idea that it's a standard. But also, you know, neither you as a manufacturer, I would guess, and certainly not us as a dealer, is interested in competing or can compete with Amazon, because we would just be getting it from Amazon and then marking it up, when I think, you know, the customer should be able to do that on their own.
Well, that's right. If you can get fresh batteries for about $17 each,
right,
you know, why would you almost pay double that,
right,
you know, to get it, you know, a different way? There's certain things that make sense to sell, you know, through a store like your store or other stores. And, you know, when you're dealing with things that are within the realm of the computer industry or the photography industry, those lines of, you know, sales,
right,
okay, for lack of a better word, are very well established and very, very, very competitive.
Right. And we'll stock some as a courtesy.
Oh, absolutely. People need to come here and
right,
be able to get a battery on a moment's notice.
Right.
But, you know, when you buy a transmitter like ours, you know, I can see for every transmitter that you buy, you might very well be purchasing 3 or 4 batteries. You know, so if you're going to do that, you know, getting an internal battery that comes maybe from a different source doesn't make a lot of sense either, because you do want all your batteries to come from one place at the same time so that you have predictable performance of those batteries.
Right.
So it just makes sense. It'll save the customer money. It's easier, I think, for you, the dealer. It's easier for us as the manufacturer. It's a win-win not to include a battery.
Yeah, and chargers, people are getting just regular single and 2 bank chargers.
Exactly. I mean, chargers are available all over the internet from many, many manufacturers.
And presumably there's a third party, one of the third party companies will come out with some professional charger.
I'm sure there will be many, many options. I mean, yeah. I can see just from our our pre-sales of this transmitter, which had been amazing. There's going to be a lot of these out there and a lot of people doing things.
And Electrosonics uses the same battery in their transmitter, and they have a charging solution.
I believe they might.
Yes.
I'm not sure. I'm feeling a little dizzy now. I don't know if I can continue.
But it is an accepted standard at this point.
Absolutely. All joking aside, Electrosonics uses the same battery. The battery is a Fuji battery.
Yeah.
It's manufactured for quite a few cameras, and I think the battery will be available for many, many years to come. And if it isn't available, we will make the batteries ourselves.
Sure.
But right now, it's absolutely available and not a big deal. So to finish this, what I would like to talk about is the ZHD. ZHD is Zaxcom High Density Wireless. Mm-hmm. We came out with this at NAB this year, 2016. This year being 2017. Here we are in January. We came out with ZHD. What ZHD was designed to do, and what it does, are a little bit two different things. What it was designed to do was to allow our customers that use hundreds of channels of wireless, like sports organizations and what have you, to be able to pack in more wireless channels in a smaller amount of spectrum. So this transmitter, like our other transmitters, is ZHD compatible. So it has different transmission modes that you set and forget. Okay, you don't have to worry about it. Mm-hmm. But it'll transmit to any Zaxcom digital receiver ever built, but it'll also transmit to the newer receivers that accept both ZHD 48 and ZHD 96.
What are the differences between those two?
Those two, the ZHD 48 is our narrowest signal, and that signal is only 50 kilohertz wide. And it fits in a channel that is 100 kilohertz wide. So we're able to pack in 10 transmitters in 1 megahertz of spectrum. So this transmitter will work with that system.
So 550.1, 550.2, 550.3, and so on.
Exactly right. And we're also able to utilize what we call ZHD 96, which is a little bit wider signal. It's 100 kilohertz wide, and the minimum spacing on that is 200 kilohertz. Yeah, the reason that we do that is for those people that have to use IFB while they're transmitting, the latency on ZHD 48 is a bit much. Okay, that mode actually, the current latency with this transmitter is about 17 milliseconds.
How many?
17.
Wow, okay.
Yeah, well, it's still about half of one video frame. It's not very significant.
Right.
But if you're listening to an IFB at the same time, and if you have other delays, through digital processing in the system.
Sure, it's all cumulative.
It gets longer, yeah.
Okay.
So what we did is we came up with ZHD 96, which is about a 5.5 millisecond latency with this transmitter, which is more than sufficient for any broadcast application. Mm-hmm. Of course, if you're recording something, none of this really matters, but it's really only the live kind of thing. And this, this transmitter, again, because it is not specifically focused for one group of people. I mean, this transmitter has what I like to call something for everybody. If you look, because it used to be, if you wanted a small transmitter, maybe it wouldn't run very long, or it didn't have very high power,
right?
Or it didn't have a great feature set. Now you've got it all. And with ZHD, what you have with this is future-proof technology. Because you buy this transmitter today, if the FCC changes the rules going forward, where they're not going to allow you to have as wide a transmission as you can have today, this is already doing transmission that is ridiculously narrow. So the ability to use this into the future, way into the future, is there. So ZHD was really designed, to be very narrow. The unintended benefit of ZHD is that ZHD is really good with reflections. The problem with digital wireless is, and you have the same thing with analog wireless, but in digital wireless, if you have very, very bad reflections and you don't have immunity to it, the system can lose reception.
Because of multipath cancellation?
Well, that's right. Because of multipath. It's not necessarily cancellation. I mean, things can add together, but you do have things that time-wise don't line up anymore.
Right. In analog, it would be beneficial if they added together. In digital, I imagine it's not so beneficial.
Well, with ZHD, it is beneficial. Yeah, because the nature of the ZHD modulation is such that signals that add together are beneficial. So utilizing ZHD48, we've had some incredibly crazy situations that were absolutely just 100% fault tolerant. As you said, reflections are beneficial when using ZHD48, a little less beneficial in ZHD96, but it was a benefit that is really great because if you're going to be working in some environment where you've got a lot of big metal dumpsters or you're in a bank vault or just some situations that are just highly reflective, you can go to ZHD 96 or 48 and have a system that is absolutely rock solid for that. And again, designed really so that you can space the transmitters closely together. Our XR modulation that we came out with about 3-4 years ago, where we did the video on the Hudson River, that modulation is still the best for signal to noise. And that's what we recommend our customers use every day. But again,
and XR means extended range. Extended
range, that's right. It's our most easily decodable modulation.
And so what's the latency like then?
Oh, it's the same as our ZHD 96. It's about 5.5 milliseconds. Yeah, I mean, basically our modulation that has the least amount of latency is our regular US, what we call US mono. And that's about a 3.3 to 3.5 millisecond latency. Again, very much in common with other wireless systems, and really an absolute non-issue.
But XR is a step up from that in terms of range and fidelity, or just range?
The fidelity is identical. It's the range that is better, because XR is ridiculously decodable. You only need a signal that's about 6 to 7 dB above the RF noise floor to be decoded.
Wow.
And that's what we use going across the Hudson River, because the range of that is just amazing. I mean, we have gotten range on this, easily, half a mile with what we're doing now. So, again, there's no benefit to analog wireless when it comes to range or any of that anything like that. So, yeah.
And talk to me about NeverClip. This was the other sort of more general Zaxcom topic.
Sure. NeverClip we invented about 5-6 years ago. Zaxcom has a patent on NeverClip. So with NeverClip, we utilize 2 A to D converters on the audio that comes into the transmitter. We also do this on our recorders as well. And we offset that audio. And then taking the audio into the DSP, we very cleverly combine the audio back together to extend the dynamic range. And with this system, you get a true extension of dynamic range. So you get the benefits of a really low noise floor, but you also get the benefits of being able to have audio go beyond the clipping point of one converter, where it's still handled perfectly by a second converter, and then the DSP is basically gluing those ranges together. By doing that, we absolutely eliminate the limiter distortion that is common to all wireless transmitters, because they have to be able to handle high-level audio without clipping.
So as an end user, I set my gain normally, sort of peak modulations to be, a couple of dB below full scale on the meter, right?
Right.
And behind the scenes, what's going on is there's actually 2 A to D converters.
That's right.
And one is set to some nominal level below my gain setting, and one is set to some nominal level above my gain setting. Is that right?
Well, I mean, the levels are set at a
Relative to
yeah, they're set at a distance from each other.
right.
You know, and you have the ability by changing the gain of the transmitter to move that around.
But it's all relative. The two inputs are changed relative to my gain setting, and I'm not aware as an end user that there's two A to D converters.
You're not aware. This is a system that is absolutely transparent to you. It's transparent to post-production.
Uh-huh.
The thing is that post-production has to boost up the gain because someone is whispering. Okay, what happens is you boost the gain up in post, but they don't pick up any noise because there's no noise in the file. You know, what we have done is very cleverly extended the dynamic range of the recorded file with Neverclip so that instead of the typical 20 dB of noise that's sitting in that file, it's just all audio dynamic range.
All of the bits, or most of the bits, have signal. Very
Yeah,
few.
of the 24 bits that are contained in the file,
Right.
I would say most likely at least 22 of them, which would be about up to 132 dB. Let's say at least yeah, at least 21 to 22 of them are actual audio, as opposed from the typical kind of thing where, you know, look at it this way, okay? When it comes to 24-bit audio, the 24-bit audio is used by a lot of manufacturers to describe what they do. And
Right.
frankly, it's bullshit. If someone tells you they're using 24-bit audio, that would mean that they have 144 dB of dynamic range. And no one has 144 dB dynamic range. We are the closest to coming out or providing, you know, these higher dynamic range signals.
Right, but arguably even, you know, to find a person that can speak with 144 dB.
Well, it doesn't, yeah.
And then a microphone that can capture that.
Yeah, it's impossible. Right. So, you know, the term 24-bit audio, they're marketing bits, okay?
Right.
So when you look at, you know, the files and the dynamic range and all, basically the way you calculate it is a bit of audio is 6 dB of dynamic range. So if you have a signal that's only 100 dB of dynamic range, I mean, you can do the math and figure out that it's only about 18 bits worth of actual signal, not 24 bits. So, you know, I think, you know, when you look at the number of bits and how the bits are used, Neverclip is able to use the 24 bits almost to their full extent.
Right.
And without Neverclip, you can't. Because we are using that, and again, it comes down to post-production. When they get that file has usable audio, you know, throughout almost every bit, where, you know, traditional files from, you know, every other manufacturer is going to have, you know, some number of noise bits based on the actual dynamic range, which, you know, typical dynamic range of a recorder would be about 116, 117 dB.
Sure.
For, you know, a portable recorder. For a wireless microphone, the actual dynamic range would be closer to maybe, you know, 90 to 100 dB for a typical, you know, wireless. Maybe an analog wireless would be, you know, about 80 dB. Of course, the companders and noise reducers tend to artificially extend that at the expense of distortion. But Neverclip is the closest thing you can get to an actual hard wire where it's just, you know, linear, full range, extended range audio.
So it's still getting recorded as 24 bits. It's just the two A to D converters are combined in a way to maximize that usage.
Right. The, you know, basically broadcast wave files, the broadcast wave file standard, the basic standard, is 24 bits per sample.
Right.
So that is 24 bits. That doesn't mean you have 24-bit audio.
Of information.
No, absolutely not. You know, again, with
And that's what we were talking about, where you're lucky if you sort of get 18 real.
You're lucky
bits.
if you have 18 real bits, and that's what post, you know, that's where it comes to post, where if you're giving them, you know, more active bits, when they push that fader up because someone's whispering,
Right.
if you have more bits of audio, the noise doesn't come up. Right. If you don't, You're just pulling up the noise.
You're just pulling up the noise in those least significant bits that are sort of random
Well, that's right.
noise. Yeah.
You're going to hear the whispering louder,
Right.
but you'll also hear the noise in the background, and that's really the difference. And that's why Neverclip is so good.
And I think just for the sake of completeness, we should say this applies to the acquisition and therefore the recording, not necessarily noise in the room or noise that's in the system for other reasons.
Yes.
This is strictly just sort of on the acquisition side.
Absolutely right. Yeah, we're talking about recorded fidelity. We're not talking about eliminating air conditioner noise. I mean, those are things that a system like Cedar is really good at.
Right.
That's not what we do. We make sure that whatever you put into the wireless, whatever you put into our recorders is going to be as absolutely pristine as possible. That's what we do.
So one of the things that is exciting about this technology, digital wireless in general, but specifically your implementation of it, is I am sitting at the sound cart with my all Zaxcom recorder and control surface. I reach for the gain on my control surface. Thanks to ZaxNet, I am directly controlling the gain of the preamp right before the A to D converter in the transmitter.
Correct.
Right? And then it immediately gets translated to digital signal, digital electronic audio, and then a digital wireless signal.
Yes.
My receivers are taking that digital signal in and processing it into AES audio, which is then being output into my digital recorder.
Yes.
And so it only hits one A to D stage.
Well, that's right. It is.
And one A to D stage all the way through post-production.
Oh, that's right. I mean, that audio should, and probably at this point in time, will never be analog audio again until it's heard, through
By somebody watching it.
By someone watching it in a theater, in a living room, what have you, which is a wonderful thing. What I want to point out is along those lines, a digital wireless transmission system, is the only way to get audio from a transmitter that's been digitized, to the receiver and have exactly the same stream of ones and zeros unaltered at the receiver, When you think about it, you think about, what other systems can do to the audio, companded systems, whether they be analog or DSP based. All of those systems throw information away.
Right.
They're all, they all have to make room for the audio that is psychoacoustically important, so that at the other end, what you hear is that audio as pristine as it can be. And don't get me wrong, those systems sound absolutely great, and people use them every day. They work perfectly.
Just like MP3s.
Just like MP3s.
Which is a very controversial, deliberately controversial statement.
Right, but the point I'm trying to make here, and hopefully am making, is that, if you want the closest representation of what is going into the microphone on the transmitter, you've got to have a digital transmission system, 100% digital. I mean, basically, that's how you do that. And many sound mixers, film, TV, that are on the high-end productions, absolutely have heard this difference. And right now, I would assume in the signal chain that we have going right here, this is digital to our receiver, and I hope that you're processing it digitally and staying in the digital domain, so that people are only hearing the single conversion to the point where they get it at their house. If not, it's okay.
Yeah, I think ironically we are going into a digital mixer, but we're probably
using the analog output. It's okay. Yeah. I know you're new at this, and it's okay.
Right. I'm learning. I'm learning.
I know. Look, we'll get you going. Okay, we make gear.
Someday.
Yeah. But the point is that for the people who are out there, that are using our system, you're absolutely right. It is a 100% digital signal path, and you can stay away from the limiters and the compressors and the noise reducers and the analog distortions in the signal link, all by staying with our system with a single A to D conversion from the transmitter. That's it.
That's great. Thank you.
Thank you, Peter. This is great.
All right, so thank you for watching. As always, you can see our archives on Vimeo and YouTube, and on Facebook and Twitter. And any ideas that you have for future shows, please email them to info@gothamsound.com. Thanks for watching.